this lesson we're going to discuss circles and arcs. So first let's discuss exactly what a circle is. Okay, everybody kind of should be able to identify a circle, but to know the exact definition is sometimes helpful. So a circle is a set of points, alright, that are equidistant to a given point. Alright, that given point is called the center, okay? We'll just call that the given point. So if we look at the circle on the right here, obviously all of these points right here along this circle are all the same distance to that center point. Okay, so P is the center, obviously. And to name a circle, you draw a little circle with a dot in the middle and name it with its center. Okay? Next we have a radius. Alright, a radius is from the center to the edge of the circle. Alright, for example, the segment PC would be a radius. PA would be another radius, and PB would be another radius. Plural for radius is radii. Next we have diameter. Diameter is all the way across the circle, and it has to go through the center. Alright, in this example here, AB, segment AB would be the only diameter. Notice the diameter is always 2 times the radius. And the radius is always exactly half the diameter. Alright? A couple of extra notes to write down. Finally, we have a central angle. Central angle of a circle is an angle whose vertex is the center of the circle. Alright, so there's a number of different angles in here that are central angles. For instance, we have angle CPA. Alright, CPA would be that angle right there. Alright, we can also say angle CPB. That's a central angle. Alright, and there's also angle APB. That's that diameter is a central angle. Okay. Alright, so we're going to talk about a real-world connection example here. So here on the right we have a pie chart. Okay, so on this pie chart, it's broken up into different sections, and this, if we read it, it's a graph that studied hour-by-hour activities of 3,600 people. Alright? The participants were between 18 and 90 years old. Each participant was sent a 24-hour recording sheet every March for 3 years. Alright, for 2 years it looks like. Oh, sorry, 3 years. So, collected the evidence, and it looks like it's broken down by sleep, entertainment, food, work, and so on and so forth. It looks like people sleep more than they do anything. Alright, so what we're going to do here is we're going to use this pie chart, and we're going to find the measure of each central angle in the circle graph. Alright, so well, let's start with sleep first. Alright, now to figure out the angle, so I want the measure of that angle right there. Okay, figure out the measure of that angle. what we're going to have to do is we're going to have to use the percentage. And I know a circle is 360 degrees all the way around. So all I'm going to do is calculate the percent of 360 to figure out the angle that that particular section represents. So sleep would be 31% of 360. To calculate 31% of 360, we're going to take the decimal. Now the decimal point is right here, so I'm going to move that decimal back 2 spots to the left. So that's going to be 0.31, and we're going to multiply that by 360. And this is going to give us the measure of that central angle. Alright, so if I calculate that 0.31 times 360, we get approximately 111.6 degrees. Okay, and I'll show you. We'll do one more. Let's do work, for instance. I'm not going to do them all, but you can get the idea. Work is 20% of the total 360 in a circle. So move that decimal 2 spots to the left, so it's 0.20 times 360. And that one is exactly 72 degrees. So those are 2 examples of how to find the central angle in a circle graph. Okay, here's another example of figuring out the measure of a central angle created by a circle graph. So in this particular circle graph, it wants me to find the measure of the central angle created by 45 to 64. So 45 to 64 was going to be the pink section, okay, which represents this piece of the circle graph right here. So it's going to be 40% of 360. So that's 0.40 times 360, and that should give us our answer. Let's calculate that. And I got 144 degrees for the measure of that central angle right there. Okay, now let's talk about some arcs. Okay, there's 3 types of arcs. Alright, and what an arc is, let's define that first. Alright, what an arc is part of a circle. And I'm referring to the edge of the circle, okay, the outside edge. Okay, so it would kind of be like the crust on a piece of pizza. Alright, the crust would represent an arc. Alright, so first we have a semicircle. A semicircle is exactly 180 degrees. So you can see this semicircle right here. Alright, that arc is exactly a half circle. So that arc TRS is called a semicircle. You can see that when we name an arc, we use 2 to 3 letters, and we always put a little mini arc over top. Alright, next we have a minor arc. A minor arc is less than 180 degrees. So if we look at this example, this arc right here in pink is a minor arc. So that's arc RS, and that's a minor arc because it's smaller than a half circle. And last we have a major arc, which is greater than a half circle of 180. Alright, so this arc right here, arc RTS, that's greater than 180, so that's called a major arc. So we're going to go to this circle down here at the bottom, and we're going to identify some of these arcs. So first we have all the minor arcs. So I'm going to go ahead and I'm going to highlight these in yellow. So one arc I see here would be that arc right there. Alright, that's going to be arc AC. It's one of our arcs. We have arc CE. We have arc DE. It looks like there's one more, arc AD. Those are all arcs that are less than a half circle. Alright? Next I'm going to do the semicircles. So these are the arcs that are exactly a half circle. So if I look at that arc right there, that arc would be a half circle. So that's arc ACE. Notice I have to use that third letter. Alright, we also have this arc right there, which is arc CED. And see, there should be another one here. There's that arc right there, which is arc ADE. And I believe, oh, there's one more. I see another one here. This one right there, that would be arc DAC. Those are all semicircles. Alright, let me clean up my board here. Alright. And last, we're going to look at the major arcs that contain point A. So there's point A. We want a major arc that contains that point. So it's got to be bigger than a half circle. So what about that arc right there? That works. That would be arc DA, and we'll name it DAE. Notice the first and last letters are the ones that it begins with and ends with. Okay? Let's see if I can find another one. How about the one that goes all the way around like that? That's another one. So that would be arc CAE. Would be another arc. That's a major arc and goes through point A. So, are there any other ones? Let's see. How about this one here? How about EAD? Actually, that's the same one we named down here, just the other way around. CAE, we did that one. That looks like it's about it. Alright, the next topic here we have, we're going to discuss adjacent arcs. Adjacent arcs are arcs that are next to each other. Alright, we know adjacent from previous lessons. We should know that that means next to. Okay. Alright, in the past we've also talked about some addition postulates. We've had the segment addition postulate, and we've also used the angle addition postulate. Now we're going to apply that to arcs. So we have the arc addition postulate, which basically says that the measures of arcs can be added together to equal a total arc. Alright? So let's use this example here to figure out some missing arcs. Alright? And one thing we want to remember too is that the central angle is equal to its intercepted arc. Okay, so if we look at letter A, alright, I want the measure of arc BC, which is that arc right there. Now that arc matches its central angle. So that's going to be 32 degrees. Pretty easy. Next we want the measure of arc BD. So let me get out a different color here. Arc BD would be that arc right there. So what I'm going to do for that one is I'm going to add up these two arcs. So that's using the arc addition postulate. So that one's going to be 32 plus 58. Alright. And that's going to be 90 degrees. Alright, let me clear my board here so I know what I'm working with. Alright, let's take a look at the next one. The next one we're going to look at is arc ABC. So I'm going to start at A, I'm going to go all the way around through B and end at C. Now, that arc contains the diameter, so I know that's a semicircle, which is 180. That's not that bad. Alright, and then finally we have arc AB, which is this guy right here. To figure that out, I know this arc is 32, and I know that whole arc right here is 180, so I'm going to take 180 and subtract 32 from it. Alright? Do that right, we get 148 degrees. So those are our answers for those examples of finding arcs, adding up arcs, subtracting from 180, whatever the case may be. Okay, the next thing we're going to discuss about circles and arcs is something called the circumference. And what the circumference is, which we've talked about in the past, is the distance around a circle. And there's two formulas for circumference. There's pi times the diameter, and there's also 2 times pi times the radius. Okay? So let's try an example for circumference. Alright? This example, we have an automobile car's turning radius is 16.1 feet, and that's labeled on our diagram. And it says the distance between the two front tires is 4.7 feet. And that's represented right there. In completing the outer turning circle, how much farther does the tire travel than the tire on the concentric inner circle? Alright, so my plan of attack here is first I'm going to find the circumference of the outside circle. So I'll call that circumference with a subscript of O. And again, the easiest way to do this is 2 times pi times the radius. So if I looked at the outside circle has a radius of 16.1. So that's going to be 2 times pi times 16.1. So if I calculate this without calculating pi, let's just take 2 times 16.1, and I'm gonna leave my answer in terms of pi. So this is 32.2 pi. Now what I want to do is find the radius, so I can find the circumference of the inner circle, which again is 2 times pi times the radius. So the radius would be this length right there. To do that, we're going to take that radius they gave us before, 16.1, and we're going to subtract this guy, 4.7, from that. I get 11.4 for the radius of that. So 2 times pi times 11.4. And again, I'm just going to multiply 2 times 11.4, and I get 22.8 pi. Now it wants how much farther. So now what I'm going to do is I'm going to take and subtract these. So I get 32.2 subtract 22.8 gives me 9.4 pi. So this is our answer in terms of pi. And if I want to calculate that, I can just simply multiply it by pi, and I'll have my answer. If it says to round it to something, I can. That's approximately 29.5 feet longer. These are the same, by the way. Okay, next let's talk about arc length. Okay, arc length is just simply part of the circumference. Alright, so to find the measure of an arc, you use the central angle. To find the length of an arc, we're going to have to use this formula right here. Alright, so we're going to take the measure of the arc we're dealing with, divide it by 360, and multiply it by 2 pi r, which is the circumference. So let's try an example. This one says find the length of arc XPY. Now XPY is this arc in red. So I'm going to take the measure of the arc, which is this angle right here, or this measure, which is 240. I'm going to divide it by 360 and then multiply it by 2 times pi times the radius. Now the radius is labeled right here 15 centimeters. Alright, now once my answer in terms of pi, which means don't calculate pi, we're going to calculate everything else but pi. So let's see. First thing we can do is we can multiply those two together. So that gives us 240 over 360 times, that would be 30 pi. Over here I can cancel my zeros, and I think of a number that goes into 24 and 36 evenly. How about 12? So I can reduce that. 12 goes into 24 twice, 12 goes into 36 3 times, so now we're looking at 2 over 3 times 30 pi, and I know 3 goes into 30 10 times, and then I can multiply 2 times 10, that gives me 20 pi. That's my answer in terms of pi. Alright, that was quite a lengthy lesson, but hopefully you got a lot of information about arc length, circumference, major arc, minor arc, semicircles, all that good stuff, radius, diameter. So those are some basic skills we need to know about circles for the future. Alright, thank you very much.